So there are three things in chemistry. First is acid, which sour in taste, base, which is little bit bitter in taste. And once the acid and base combines together, they will give you salt plus water. That is a neutralization reaction that we have learned in 9th standard. Today we will see a comparative study of acid, base and salt, and one more term has been added, that is alkali. We will see that. First it is acid. A compound when dissolved in water yields H3O+. What is H3O+? H3O+ is hydronium ion. So HCl, it's in aqueous phase. It's a reversible reaction. When arrows are in both direction, it shows that this reaction is reversible. That from left to right also it is possible, and after it gives H plus and Cl minus, it might come back also. It comes back and it gives this H plus and Cl minus, because they are oppositely charged. They'll react and form HCl. So this is a continuous reaction between HCl and H plus and Cl minus. So HCl, when it is in aqueous phase, aqueous means when you are dissolving in the water, it gives you H plus and Cl minus. Now after that, here we have taken aqueous phase. Yes, because this is HCl, you are mixing in water. So let us see from the perspective of water. When HCl gives you H plus and Cl minus, this H plus will react with H2O. And this is also a reversible reaction, and it will give you H3O plus. So HCl plus H2O, it will gives you H3O plus and Cl minus. If you will see it here, this HCl and H2O, it will gives you H3O plus and Cl minus. This we have learnt earlier, that from H2O, the dissociation product will be H plus and OH minus. So from that you will get HCl and H2O and H3O plus and Cl minus. This H plus and H plus will get cancelled, and OH minus will combine with H3O plus and it will gives you Cl minus. Now that is all about acid. So acid will gives you H3O plus ion, that is hydronium ion, when it is combining with water. This will true for any acid. Then base. What are the base? A compound which react with hydronium ion of an acid gives salt and water. This is same as neutralization reaction. So base will react with hydronium ion as good as when it is reacting with acid. As good as when it is reacting with acid, because acid gives you hydronium ion, and here they have given when base reacting with hydronium ion, it will gives you salt and water. For example, CuO, copper oxide, reacting with acid, that is HCl, it will gives us CuCl2 H2O. This is a salt and this is water. Again CuOH twice, copper hydroxide will react with acid. This is our base, copper oxide and copper hydroxide, both are base. Reacting with acid, it gives us salt. This is copper chloride and copper sulfate, gives us salt plus water. Then an alkali. A compound when dissolved in water yields hydroxyl ion. What is the meaning of hydroxyl ion? It is OH minus ion, hydroxyl ion. So NaOH, it's an alkali. So sodium hydroxide, it is in aqueous phase. When it is dissolved, when we are dissolving, it gives us Na plus and OH minus. So these are the hydroxyl ion. It will generated when we are dissolving in water. So acid and alkali, when we are dissolving, it simultaneous, it gives respectively H3O plus and OH minus. Whereas base is a compound which reacts with acid or hydronium ion, it gives us salt and water. This is the basic idea about acid, base and alkali. Now we will see the basic classification between acid and base. So there are 4 criteria to classify acid and base. First is source of an acid or source of base. Source means from where we are deriving the acid and base. Molecular composition, the molecular formula of acid and base. Strength of acid and base. When we are talking about strength, then we are talking about the concentration of H plus ion and OH minus ion. Then basicity of acid and acidity of base. Particularly this is also related to how many H3O plus ions will be generated when acid is in the aqueous medium and how many OH minus ion will be generated when base will be in aqueous phase. So these are the criteria. One by one we will look, and last two we will see in detail. First, source of an acid. There are two bifurcation into that. First is organic acids. What is the meaning of organic acid? Those acids which derived from plants. For example, citric acid or tartaric acid, the acids which we are getting from the lemon or from the melons and all. So these are the acids which are organic acids. Inorganic acids. What are the inorganic acids? Those derived from the minerals. Their source is not a natural. So they are hydrochloric acid or sulfuric acid. So basically there are two sources, organic and inorganic, under the source of an acid. Now molecular composition. Molecular composition of acid is, first is hydroacid and other one is oxyacid. The acid which combines with hydrogen, combines how? That in that hydrogen and non-metallic elements will be there. For example, hydrogen. This is hydrogen and Cl is non-metallic element. The Cl and bromine, they are non-metallic element. They are combining with hydrogen and they are making hydroacids. Oxyacids. The hydrogen is combining with another element like nitrate and sulfate. So nitric acid and sulfuric acid will be generated. So basically there are three parts, that hydroacid and oxyacids. Now strength of acid and base. There are two criteria in that. Either they are strong or they are weak. What is the meaning of strong? When you are mixing an acid with the water, if the concentration of H plus is more, for example HCl, if the concentration of H plus is more, that means your acid is strong. For example of base, if it is generating more OH minus ion, that means it's a strong base. If it is not generating more H plus ion, or if it is not generating more OH minus ion, then they are referring a weak acid and base. It is that the strength of acid and base is directly depending upon the concentration of H plus and OH minus. If the concentration is more, the acid and base are strong. If the concentration is less, the acid and base are weak. Now basicity of acid and acidity of base. How these two are different? When we are talking about the basicity of acid, it always refers to H3O plus. When we are talking about the acidity of base, it is always referring with OH minus. If the basicity of acid means how many ions, H3O plus, how many ions, that means how many hydronium ion will be generated when acid will be in aqueous medium. And what is the meaning of acidity of base? How many hydroxyl ion will be generated when it is in the aqueous phase. So this is the bifurcation of or classification of acid and base based on these four criteria. These two we will see in detail. Now let us see the bifurcation of basicity of acid and acidity of base. First of all, what is this term meant by? First of all, basicity of acid. So that means the number of H plus ion will be generated per molecule of acid. That means one molecule of acid and how many H plus ion it is generating. That this concept is referring to the basicity of acid. Now what is the meaning of acidity of base? That number of OH minus ion per molecule of base is generated is referring as acidity of base. Don't get confused. When we are writing acid at last, see the number of H plus ion. When we are writing base at the last, we have to write the concentration of OH minus or number of OH minus ion and write what is opposite to this. Again, basicity of acid, that means number of H plus per molecule of acid. Acidity of base means number of OH minus per molecule of base. So in one molecule, how many H plus ion is generated is referring to basicity of acid. When we are writing acid last, see the number of ion of H plus. When we are writing base last, see the number of OH minus ions. Now there are three types of acids as per the basicity of acid. First is monobasic acid, second is dibasic acid, third is tribasic acid. What is monobasic acid? That is, it generates one H plus per molecule. For example, hydrochloric acid. If it will dissociate with H2O, then it is giving you one H3O plus and Cl minus. It dissociates in one step, and so the basicity is 1. Why the basicity is 1? Because it generates at 1 H plus per molecule. One molecule of hydrochloric acid, it gives 1 H3O plus. Now dibasic acid, same as monobasic. Here it gives 1, here it gives 2 H plus per molecule. And here the basicity is 2. Why 2? Because it generates 2 H plus per molecule. The example is sulfuric acid, H2SO4. It dissociates in 2 steps. It requires 2 steps to dissociate. First, H2SO4 with water, it gives you H3O plus and HSO4 minus. In first step, one hydrogen ion will be replaced from H2SO4. In SO4's combining capacity is -2. So it is combining with 2H plus. So in first step, first H plus has been removed, and in second step, second H plus has been removed. So here in first step, first H plus has been removed, so remaining is HSO4 minus. And in the second step, HSO4 will again combine with H2O and it gives hydronium ion and SO4 minus 2. At the second step, it completely dissociates. It dissociates in 2 steps and it gives 2H plus per molecule. That's why it is dibasic acid. Now tribasic acid. This acid dissociates in 3 steps. What is an example? H3PO4. And it gives how many H plus ion or hydronium ion? 3 hydronium ion while it dissociates. And what is the basicity? 3. How many hydronium ion will be generated? That many its basicity. Now let us see the dissociation step. Now first of all, PO4 minus, phosphate. It has a combining capacity of 3. So it combines with 3 hydronium ion. So while dissociate one by one, we are taking out the hydronium ion. So in first step, first hydronium ion has been dissociated and it is replaced. So the remaining ion is H2PO4 minus. In second step, H2PO4 minus will combine with water and it gives H2PO4 minus 2. And and here hydronium ion. Here H2PO4, HPO4 minus 2 will combine with water and it gives PO4 minus 3 and hydronium ion. One by one hydrogen will be replaced and complete dissociation will happen in 3 steps and it gives 3 hydronium ion at the end. So this is how the monobasic acid, dibasic acid and tribasic acid will work out. Mono means 1, di means 2, tri means 3. Mono means 1H plus, it gives, the acid gives 1H plus. Di means this acid gives 2H plus. Tri means this acid gives 3H plus. Now let us see what is acidity of base. As I have told you earlier, the number of OH minus ion per molecule of base. In this also there are 3 types. Monoacidic base, monoacidic, diacidic base and triacidic base. Monoacidic base means it gives 1 OH minus per molecule. Now here there is a little difference that when acid will dissociate, it needs steps. If there are 2 replaceable H plus, it dissociates in 2 steps. When there are 3 replaceable hydronium ion, it requires 3 steps to dissociate. But in the base, it requires only 1 step to dissociate. Within 1 step, the whole 2 or 3 hydroxyl ion will be dissociated. This point you need to remember. That it gives 1 OH minus per molecule. So NaOH, sodium hydroxide, will dissociate and it gives 1 hydroxyl ion and acidity is 1. Here we have written basicity because it is monobasic acid. So we are writing basicity. Here it is monoacidic base. So here we are writing acidity. So acidity of monoacidic base is 1. So if, for example, if they are asking a question, what is the acidity of NaOH? Then you have to write 1 because it is generating 1 hydroxyl ion and dissociation. Now diacidic base, it gives 2 hydroxyl ion and all the base requires only 1 step for dissociation. So calcium hydroxide will dissociate and it gives Ca plus 2 and 2OH minus. Now triacidic base, it gives, as name suggests, it gives 3 hydroxyl ion per molecule. So aluminium hydroxide, it contains 3 OH. So while dissociate, it gives Al plus 3 and 3 OH minus. And the acidity is 3. If it gives 3 hydroxyl ion, the acidity is 3. If it gives 2 hydroxyl ion, the acidity is 2. So what is the basic concept about basicity of acid and acidity of base? In how many steps they will dissociate and how many number of OH minus or number of H plus ion will be generated in per molecule of acid or base. Here 1 H plus will be generated, 2 H plus will be generated, 3 H plus will be generated. Here 1 OH minus will be generated, 2 OH minus will be generated, 3 OH minus will be generated. And accordingly they are called mono, di and tri basic acid or acidic base. Let us see the mechanism of hydronium ion and hydroxyl ion, how they are formed and why they are formed. When we are adding acid to water, hydronium ion will be formed, and when we are adding base to water, hydroxyl ion will be formed. What is the property of water? That it is a polar covalent molecule. Now, to check out what are the covalent molecules, and there are 2 types of covalent molecules, polar covalent molecule and non-polar covalent molecule. To know more about this, check my videos based on chapter 2, chemical bonding. So water is a polar covalent molecule. That means we can observe a charge separation within molecule. So, and it shows charge separation. What is the meaning of charge separation? One will acquire slight negative charge, other one will acquire slight positive charge. Let us see that first. So this is two hydrogen having one electron, and this is oxygen having 6 electron in its outermost shell. So hydrogen and oxygen will combinedly form a bond and they are forming a molecule. But within water molecule, because there are two unused lone pair of electrons, oxygen will develop slightly 2 delta negative charge. With one unused pair, it develops 1 delta negative charge. With other one, it develops another one. So the oxygen will develop 2 delta negative charge, while the hydrogen, both hydrogen will develop delta positive charge, because the electrons are more towards the electronegativity is more towards the oxygen and not towards the hydrogen. So water molecule is observing a charge separation within molecule. Both the hydrogen ion will observe little bit positive charge, partial positive charge, and oxygen will observe partial negative charge. First of all, we'll see how the hydronium ion will form. So this is our water molecule when we are adding acid. HCl, hydrochloric acid, that is again a polar covalent molecule. So it also observes a charge separation within molecule. So H will carries delta positive charge, chlorine will carries delta negative charge. Now within water molecule, these two lone pairs are unused. So this H plus of acid will attracted towards the unused pair of electrons. Now if you will see here, the hydrogen has 1 atomic number, and if you will see the electronic configuration, then it is 1. And if it donate 1 electron, it becomes H plus. It donates 1 electron and it becoming H plus. So H plus doesn't have any of the electrons. So this H plus will go and combine with this H plus will go and combine with this water molecule. This is a complete water molecule and this is our H plus which comes from the HCl. So this H will combine here. Since this hydrogen is using the electrons of oxygen, it doesn't have any electron because it is H plus. So the electron is sharing both the electrons from itself. So this is coordinate covalent bond and this whole molecule will observe positive charge on it because oxygen has contributing both the electrons and negative charge little bit surpassed. So that's why this will observe positive charge on it and Cl minus will be left behind from this. So you can learn more about this in chapter 2 chemical bonding, coordinate covalent bond. So here this is a mechanism of how the hydronium ion will be formed. Here if you will see, this is 3H, so H3O plus. So this is a formation of hydronium ion and which will form only in presence of acid. When any acid will gives H plus, dissociate in a water and gives H plus, then only that H plus will combine here and gives you hydronium ion. Now what will happen in the case of hydroxyl ion? So this is our hydroxyl ion. When ammonia mixing with the water, it gives NH4 plus OH minus and gives NH4 OH, a base. Let us see the mechanism. This and with 3 hydrogen and nitrogen also has 1 unused lone pair of electrons. So it carries 1 delta negative charge and rest all hydrogen will carry delta positive charge. A charge separation they can observe within the molecule. Here this is a water molecule. There is also a charge separation in the water molecule. So here what will happen? This H plus of water molecule H plus of water molecule will attract it towards the lone pair of nitrogen. This unused pair of electron which nitrogen carries, it has a negative charge in it, and this is positive charge. So this will attracted towards here, and this, since this is H plus, it doesn't have any electron, so the nitrogen will donate its 2 electron to hydrogen, and that's why they are forming coordinate covalent bond, and this NH4 plus will observe positive charge on it because nitrogen has donated both the electrons, and the OH minus will be left behind. From where? From the water molecule. If you will see the water molecule, there will be charge separation like H plus and OH minus. So H plus will combine with ammonia and OH minus will be left behind. So that's why the base always gives OH minus. Base will always give hydroxyl ion, whereas acid will always give H3O plus, that is hydronium ion. There are various methods by which we can prepare acid and base. So let us see preparation of acids and base. Here I have differentiate the acid and base. So one by one we will take. First, acid from non-metals and base from metals. Non-metal, when react with oxide, it gives non-metal oxide and they are acidic. Metal, when react with oxides, it gives metal oxide and they are basic. So acid from non-metals, so our chlorine is non-metal. When it reacts with hydrogen, it gives us hydrochloric acid. Here metal, it reacts with oxygen and it gives us sodium oxide, and they are basic in nature. The second type, acid from acidic oxide. Whenever the acidic oxide is there, they are from non-metal. For example, carbon, sulfur and phosphorus. Carbon and oxide, carbon's oxide, carbon dioxide. Sulfur's oxide, sulfur dioxide. Phosphorus oxide, phosphorus pentoxide. When they are dissolving in the water, then they are giving respective oxides. Carbon dioxide plus water, it gives us carbonic acid. Sulfur dioxide dissolved in water, it gives us sulfurous acid. Phosphorus pentoxide dissolved in water and gives us phosphoric acid. So non-metal oxide, when dissolved in water, it gives us acid. Now what about base? It is from basic oxide. So it is from metal oxide. When metal react with oxygen, it gives us metal oxide and they are basic in nature. Potassium and sodium, both are metal. When they dissolve in water, they gives us potassium hydroxide and sodium hydroxide. Both are basic in nature. Third type, acid from salts. When potassium nitrate react with acid in the presence of heat, it gives a salt and it displaced volatile acid. From where it will displace? This hydrogen it will displace. So one hydrogen will go with this and one hydrogen will remain over here. So it will be displaced volatile acid. Now base from salt. So aluminium chloride, when react with alkali, it gives NaCl, salt and basic hydroxide, because it's aluminium hydroxide, metal hydroxide, and they are basic in nature. And it will precipitate out. This sign suggests us that it will precipitate out. Now acid by oxidation of non-metals. So sulfur, and when it reacts with acid, it undergoes oxidation and it gives us H2SO4, sulfuric acid, water and nitrogen dioxide. So here it is giving us acid. Now base by decomposition of salt. One salt you are breaking into a pieces. That is a decomposition reaction. When you are taking a one reactant and for a product you are getting 2 or 3 different compounds, then it is a decomposition reaction. So lead nitrate we are taking and it undergoes heat, then we will get lead oxide, nitrogen dioxide and oxygen. So this is by decomposition of salt and this is oxidation of non-metals. These are different types of method that by which we will get acid and base. Properties of acid and base. We'll start from chemical properties. So first reaction we will see, that is neutralization reaction. What is neutralization reaction? When acid react with base, it gives us salt and water. So here hydrochloric acid and sodium hydroxide. Whenever any reaction will be there in which 2 reactants are there, in reactant A, in reactant B. So reactant A's positive radical will react with reactant B's negative radical. So it gives us H plus OH minus, it gives us water. And reactant A's negative radical will react with, combine with reactant B's positive radical. So it will become NaCl, salt. So like this they will give us salt plus water. Another reaction in which active metal reacts with acid. What are the active metals? Those are in the activity series, they are active metals. So when active metals react with acid, they will give us salt and hydrogen gas. Here which acid we are taking? Dilute acid we are taking. It always represents with DIL, dilute. So zinc plus dilute hydrochloric acid will gives us, again zinc is a positive radical, will react with Cl. So ZnCl2, because zinc's combining capacity is +2. So they will interchange the combining capacity by crisscross method. So here it will be ZnCl2. And what left is H2 and not 2H. This will become gas. So any active metal will react with acid and it gives us salt and hydrogen gas, because always in the acid hydrogen will be there. That hydrogen will left and go as a hydrogen gas and the rest will become salt. Again, now these are series of reaction of acid with chloride, nitrate, bicarbonate and carbonate. Let us first see chloride. How this reaction will go? One salt will react with one acid. It gives us another salt and another acid. The reaction when one salt is reacting with one acid, as a product they are giving us salt and acid only, but the different salt and different acid. That's why it represents here salt, another, that is second salt, another acid means second acid. Let us see first chloride. So sodium chloride when react with sulfuric acid, it is concentrated in the presence of heat, then it gives us NaHSO4. How this has happened? From H2SO4, when it decomposes, it gives H and HSO4 minus. Here it will be H plus. So this H plus will react with this Cl minus, reactant A, reactant B. So this H plus will react with Cl minus and remaining HSO4 minus will react with Na plus. So it will gives us NaHSO4. So this is our second salt and this is also acid, but this acid and this acid are different. So this is acid 1 and this is acid 2. This is also salt and this is also salt, but both are different. So that's why this is salt 1 and this is salt 2. Similarly, when Metal nitrate, sodium nitrate will react with concentrated sulfuric acid. It gives us NaHSO4 and HNO3. The same way, this will bifurcate in H plus and HSO4 minus. So this H plus will react with NO3. So it will gives us another acid, that is HNO3. And this NaHSO4 will gives us another salt. Now bicarbonate. Sodium bicarbonate, when it reacts with sulfuric acid and that is dilute, then it gives us sodium sulfate, water and carbon dioxide. This two will gives us a temporary carbonic acid, that is H2CO3. Unstable carbonic acid will give us. When it react with carbonate, sodium carbonate reacting with hydrochloric acid diluted, at that time it will gives us salt, that is sodium chloride, and water and carbon dioxide. These two will together and gives us unstable carbonic acid. So there are chloride and nitrate, they are giving almost same equations, and bicarbonate and carbonate, they are giving salt plus unstable carbonic acid. Always remember, when two reactants are reacting together, especially when it is salt and acid, acid and base, active metal and acid, they are interchanging their positive and negative radical. It will help you to memorize the reaction or to guess the reaction, that what product will come. See the strength of acids and base, and let us see the difference between them. So acid and base. So strength of an acid is depending upon the concentration of H3O plus, means hydronium ion, or H plus ion. Now here the strength of base is depending upon the concentration of OH minus ion. So how this concentration of hydronium ion or concentration of hydroxyl ion will be generated in water medium or aqueous medium. So there are two criteria. Either it can be a strong acid or it can be a weak acid. Either it can be a strong base or it can be a weak alkali. So let us see the difference between these two. When it is a strong acid, it dissociates completely. Means if there are 5 molecules of hydrochloric acid, that means you are going to get 5H plus and 5Cl minus. It's completely dissociate. How much ever acid molecules will be there, all molecules will be dissociate. It dissociate completely. That's why it generates high concentration in your aqueous medium. High concentration of what? H plus and H3O plus. You can write either of one. Both are same. So when HNO3, nitric acid, you are mixing with water, or HNO3 is in an aqueous phase, it gives you H3O plus and NO3 minus. This is a high concentration of H3O plus. So that's why nitric acid is a strong acid. Another example of strong acids are sulfuric acid and hydrochloric acid. Now when it is a strong base, it dissociates completely and give high concentration of hydroxyl ion. For example, sodium hydroxide. In aqueous phase, means NaOH plus H2O, it gives you Na plus and OH minus. Other example of strong base are potassium hydroxide. Now when they are weak, completely opposite. It partially dissociate. It is not completely dissociate. Partially it dissociates, so it is generating low concentration of hydronium ion. When it is weak alkali, it is also partially dissociate and it gives low concentration of OH minus. Always remember, when it is acid, the concentration of H plus or OH H3O plus will matter. When it is base, the concentration of hydroxyl ion will matter. Now what is the example of weak acid? Acetic acid. Molecular formula is CH3COOH and it will gives you CH3COO minus and acetate group and H plus. This is a weak acid. When it is weak alkali, it dissociates partially and gives low concentration of hydroxyl ion. For example, ammonium hydroxide, it gives low concentration of OH minus. Other examples are weak acids are carbonic acid, formic acid, and weak alkalis are calcium hydroxide. So this is a difference between strong acid, weak base, and weak acid, weak alkali. It is completely depending upon the concentration of H plus and OH minus ion. If the concentration of H plus is more, it is strong acid. If it is less, weak acid. If the concentration of OH minus is more, strong base, or it is less, then it is weak alkali base. pH value of medium. This topic is under ICSE Standard 10 syllabus from the chapter 3 acid, base and salts. So first of all, what is a pH? When any solution we do have, then we will check whether it is a neutral solution or it is acidic or it is a base. So first, you all know that a handy one is a litmus paper. When there are two types of litmus paper. You must have performed an experiment in your laboratory. There are two types of litmus paper. One is red, another one is blue. When blue turns red, we will see that the solution is acidic. When red turns blue, that means the solution is basic. And on both the litmus paper, there is no change, then we can say that the solution is neutral. Now what is the meaning of that? This is our pH scale. In this, from number 1 to 14 I have marked, and this range from number 1 to 7 we term, if the solution has a pH in between 1 to 7, we term that solution is an acidic solution. If pH is above 7 till 14, then we termed as the solution is basic. Always remember, when any gas is there, for example hydrogen chloride gas, if you will put a litmus paper in a gas, you will not be able to see any color change. It has to be in aqueous solution. Why? Because an hydrogen chloride gas will not have any H plus ion, a free H plus ion. When it dissociates in aqueous solution, it will give us H plus and Cl minus. This H plus ion is responsible for color change. Any indicator you will take. Similarly in the base, NaOH, if dry palette of NaOH you will take and you will put it on the litmus paper, it will not show any color change. When you will dissolve this in an aqueous solution or in a water medium, then only it will dissociate into Na plus and OH minus, and this OH minus ions are responsible for the color change from red to blue. So always remember that acid and base, when they are dissociate, this H plus ion and this OH minus ion are responsible for a color change. So here, what is a pH? Basically, pH is a product of water. How? Ionic product of water. What is an ionic product of water? When it is H2O, what we will get from this? H plus and OH minus. So these two are the ionic product of water. So H plus and OH minus. This, in the definition we will see that what is a pH? The negative logarithm. It is a negative logarithm of the hydrogen ion, concentration expressed in mole per liter. So here 10 minus 7 into 10 minus 7. The concentration of H plus is 10 minus 7 and the concentration of OH minus is 10 minus 7. So collectively it will be 10 raised to minus 14. So here in pH we will always count a concentration of H plus ion. We will not count a concentration of OH minus ion. So if it is a basic solution, the concentration of H plus ion will be less. H plus will be there, but the concentration will be very, very less. Why? When you are dissolving NaOH into the water, what will happen? NaOH plus water. What all types of ions you will get? Na plus, OH minus from this. Again, a dissociation product of water. You will get H plus OH minus. Here if you will see, the concentration of OH minus has been doubled compared to H plus. So this H plus ion concentration will be very, very less in basic solution. So if we will check the pH range, you will get pH almost in this range, and NaOH is very, very strong alkali, so you will get somewhere after 10. The pH of this solution will be basic. Why? Because the OH minus concentration will be increased and H plus ion concentration will be very, very less. So in basic solution also H plus ion will be there, but the concentration is very less. That's why that pH has been shifted from neutral to basic. Now what are the types of indicators we are using? So these are the types of indicators we are using. First is litmus. Litmus solution also will be there, and litmus papers will be also there. The blue and red. Then methyl orange and phenolphthalein. We will discuss more about the indicators. There are two types of indicators: common indicators and universal indicators. We will discuss the difference between both two in our next segment. Indicators. Why we are using indicators? To check whether the solution is alkaline or basic. And another type of indicators which are known as universal indicator. They will show you the exact pH for the solution. Yes, we do know that this is an acidic solution, but if we want to know that whether it is a strong acid or it is a weak acid, so whether it lies in between 1 to 3 pH range or it will lie in between 5 to 7 or 5 to 6. If it is 5 to 6, it is weak acid. As it goes near to 7, a neutral pH, the strength of acid is decreasing, and as it goes from 7 to 1, the strength of acid increased. So if we want to see that whether the strength is more or less, similarly for the base, if we want to know that strength of base is more or less, whether it is a strong alkali or weak alkali, that we will get to know from universal indicator. So this is a main basic difference between common indicators and universal indicators. Common indicators will only show a color change and only show that whether it is acidic or basic. Universal indicator will perfectly show you the pH of the solution. So from pH you will obviously you will get to know that whether this is acid or base, but the perfect pH will show you the strength of acid or base. So here, these are the examples. What are the common indicators? Litmus, methyl orange and phenolphthalein. Here organic dyes we are using for universal indicators. So it indicates solution is alkaline or acidic. This is a limitation for a common indicators, where it indicates a strength of pH. For example, again, here it is a 7, here it is a 1 and here it is 14. This is our pH range. If it goes towards 1, then it is strong acid. If it goes towards 7, it becomes weak and weaker. As it goes far from 7, it is strong base, and it comes near to 7, it is weak base. So once it will show whether it is here or here, you can say that this is a weak acid, this is a strong acid. Here you can say it is a weak base, it is a strong base. So can't use to check pH. This is a limitation of common indicators. We cannot check pH through this common indicators. Utilized to see strength of acid and base. Also, we know that this is an acid, this is an hydrochloric acid, but we want to know whether this is a concentrated hydrochloric acid or diluted hydrochloric acid. Then we can also use this indicator. It will show you a pH mark, and from that you can decide whether this is a strong acid or diluted one. Can't differentiate between pH value. It will not show any kind of pH change, or it will not show whether it is a strong or weak. And here if you will see that this is one type of organic dye, it shows a 3 type of color change in between 7 to 14 pH range: blue, indigo and violet. So if it transits from blue to indigo, you can say that this is a weak alkali. If it's indigo to violet, you can say it is a strong alkali. So this is a basic difference between common and universal indicator. What are the common indicators? Litmus, methyl orange, phenolphthalein. Whereas in universal indicators, we do use organic dyes. We have seen earlier acid and base. Please check out my earlier videos for acid and base discussion. So here, what is a salt basically? A salt is a compound formed by partial or complete replacement. Partial or complete replacement. First of all, what is the meaning of replacement and why it is partial or why it is complete? So here one reaction we do have, alkali plus acid. We know that when acid plus base will react, we will get salt plus water. So this salt we are discussing, that what is a salt. So here this is alkali or base. Let me write here base. This is acid. When base and acid will react, they will give us salt. And here it is water. So here from acid there are 2 hydrogen ions. So in first replacement it will bifurcate in H2SO4. So it will give us HSO4 minus and another one is H plus. This is the first dissociation of H2SO4. So this HSO4 will combine with Na plus. From here we will get Na plus and OH minus. So this HSO4 will combine with Na plus. So we will get here NaHSO4, sodium bisulfate. Whenever H is in the middle, we will call it bi, sodium bisulfate. So this is the first salt with partial replacement. Why it is partial? There are 2 hydrogen ions, but we have replaced only 1. So that's why it is known as partial. This is also a salt, but a different type of salt by a partial replacement. In another reaction, 2 molecules of sodium hydroxide will combine with H2SO4. So here you will get Na2SO4 and 2H2O. This is a complete salt through complete replacement. Why we do need 2 atoms of Na? Because here 2 atoms of hydrogen are there. So if you want to remove, if one molecule of H2SO4 and NaOH will combine, see here, we'll see the mechanism. If NaOH you are taking, you will get 1 Na plus 1 OH minus. If H2SO4 you are taking, you will get 2H plus SO4 minus 2. So if you want to replace this H from this SO4, so you do need 2 atoms of Na plus, 2 ions of Na plus. So that's why first is a partial replacement and second is a complete replacement, because SO4's combining capacity is minus 2. It requires 2 Na and it requires 2 hydrogen. But the molecule of sodium hydroxide will only provide 1 sodium. So that's why 2 molecules of sodium hydroxide will completely replace this 2 atoms of H2SO4, because in 1 molecule of sodium hydroxide only 1 Na is there. Since here in 1 molecule of sulfuric acid there are 2 hydrogen. So if you want to replace 2 hydrogen, obviously you need 2 sodium, because sodium's combining capacity is 1. If you are replacing with any other ion which combining capacity is 2, then maybe you require 1. So here Na2SO4, and this is a complete replacement. Here there is no H. So this is a complete replacement. In this case, this both are solved through partial replacement and through complete replacement. So we have seen what is a salt. Now we will see what is the difference between acid salt and normal salt. So here this is an acid salt and this is a normal salt. What is acid salt? It formed through partial replacement. We have seen that when from H2SO4 a partially replaceable salt formed, sodium hydrogen sulfate will form. It is known as partial replacement. Why? Because there are 2 hydrogen ion and it will bifurcate. This H2SO4 will dissociate in HSO4 minus and H plus. So this HSO4 minus will combine with this Na and it will gives us NaHSO4, and this OH and again this H plus will combine. This OH and H plus will combine and gives us H2O. So this is through partial replacement. Now the normal salt will form through complete replacement. Can you guess the equation? Yes. So it will be 2 NaOH with H2SO4 will gives you sodium sulfate and 2 molecules of water. Here complete replacement has been taken place. Complete replacement of hydrogen ion. Hydrogen ion has been completely removed from the salt. So you will get here sodium sulfate. Here it is not completely removed. Hydrogen is there. Here there is no hydrogen. So that's why it is partial. And here completely removed. So it is complete replacement. Now why this is termed as acid salt? Because of the presence of H plus in the salt, it is removed. It is named as acid salt. It contains replaceable hydrogen atom. Again, if you will do a dissociation of this will be replaceable hydrogen ion. This you can again remove. This H can be removed. So this is, it contains replaceable hydrogen atom. Whereas here there is no hydrogen. So obviously it does not contain any replaceable hydrogen ion. It exhibits all the property of acid because one H plus being present in the salt, it shows the acidic character. So it will show all the property of acid. It behaves as good as acid because of this one replaceable hydrogen ion. And it do not exhibits properties of acid, obviously, because it does not contain any hydrogen ion in the molecular formula. So this is a salt, it will not show any acidic property, and this is an acid salt. Why? Because there is a partial replacement of hydrogen ion and one hydrogen ion is still there in the molecular formula, sodium bisulfate. So this hydrogen will show acidic character. This is a replaceable hydrogen ion. So that's why it is termed as a acid salt. Whereas here there is no replaceable hydrogen ion, so it is termed as a normal salt.